All right, guys, our first lesson is going to start with topic 8, acids and bases. We're almost done. We've got 2 more topics. Trying to get through it as quickly as possible, but remember, you guys have to do your part and take the notes ahead of time before I go over the lesson so that you can follow along your notes and make sure that you make any markings if you are unsure of something or if you have questions that you have to ask, okay? So 8.1, the theory behind acids and bases. 8.2, properties of acids and bases. 8.3, the pH scale. 8.4, strong versus weak acids and bases. And then 8.5, acid deposition. Of course, that's just SL. Okay, so let's get started. So in 8.1, we're looking at the theory of acids and bases. So basically, you know that acids and bases, when they dissolve in solution, they conduct electricity because they release ions. Acidic ions are going to release the H plus ions, also called hydronium ions. They can also be written as H3O plus, while the basic ions are going to be the OH minus ions called the hydroxide ions. You can see here in these 2 examples, this one has the H plus ion, that's how you know it's acidic. This one has the OH minus ion, that's why it's basic. So then you've got the Bronsted-Lowry model. I think we talked about this the other day, and how the acid is going to be the proton donor, aka the hydrogen donor, and the base is going to be the one that accepts the proton or accepts the hydrogen. You can see here in this example, HCl becomes Cl minus, so it donated its hydrogen, therefore it's an acid. Water accepted the hydrogen, therefore it is the base because it accepted the hydrogen. On the other side, you got the conjugate acid and the conjugate base that are being produced. Here's 2 more examples that we went over the other day in class. So notice, how do you know it's acidic? Because of the hydronium ion being produced. How do you know this one's basic? Because of the hydroxide ion being produced. All right, and I think this is where we left off. Water can be either amphoteric, because it can be either an acid or a base. And amphiprotic is talking about a substance that can accept or donate a proton. All right, moving on to 8.2. In 8.2, it talks about properties of acids and bases. So a pair of species differing by only 1 proton are called a conjugate acid-base pair. The location of the proton transferred should be clearly indicated. In other words, see these 2 examples here? This is the correct way to show an acid-base pair, a conjugate acid-base pair. The second one is incorrect. The second one does not show which hydrogen is being transferred. Therefore, that would be an incorrect way to show a conjugate acid-base pair. Again, here you can see CH3COOH, and then the base pair is CH3COO minus. This shows that this was the hydrogen that was lost. If you look at the bottom example, it won't show that because it groups all the H's together. And so you don't know exactly which hydrogen at which location was the one that was transferred. So you do not want to write a conjugate acid-base pair the bottom way. You want to show it this way, okay? The highlighted way. Okay, we've got exothermic neutralization reactions. Okay, so an acid and a base react in an aqueous solution to produce a salt and water. So know that those are always going to be the products of a neutralization reaction between an acid and a base. The salt is going to be the ionic compound made from the cation of the base and the anion of the acid. So you can see here in this example, this is the base. How do you know? The OH minus. This is the acid. How do you know? The H plus would be separated in solution. In a double replacement reaction, when the OH and the H come together, what are they going to form? They're going to form water. And the cation, Mg, from the base, and the anion, the Cl minus, from the acid, are going to form the salt. Okay, so what's formed from a neutralization reaction? A salt and water. When a base and an acid neutralize each other, the products are going to be a salt and water. All right, we'll move on to this one in the next video.